Comparing and subtracting decimals can be a very tricky concept for students. In this video, we're going to take a look at an error that students make and some quick strategies to fix them. Sometimes students will have the misconception that because a number has more digits, it is larger. So look at the example below, 21 minus 18 and 9/10. Some students may want to flip these numbers in this number sentence because 18 and 9/10 is 3 digits and 21 only has 2. So you see this mistake arise. Well, what can you do? The first thing you need to do is make sure that your students have a very clear understanding of the numbers. And to get this, you need to have them build. So pull out those place value blocks, get out the money, or if you have place value disc, do it. I love place value blocks for this, but money is something that children also tend to gravitate towards, and money is something that they understand and place a lot of value on. So don't be afraid to get out those coins and dollars. As your students are building these numbers with these various objects, have them record the numbers into a place value chart. This is very, very important. This is your diagnostic step. Do they truly understand what place value means? Do they understand where the tens place is, the ones place is? Do they understand what the decimal means, less than a whole? This is a great step and a great evaluation for you. Just as a quick side note, I would just say that this is not something I particularly would teach to a whole group unless the whole group seems to be struggling with it. My guess is, of your students, you may have 5 to 6 that you'll need to pull for a small group that would have this misconception. So the third step in this is to make your number sense interactive. I like to play games or do a quick number talk every day to get the students thinking, get them a quick build, get them something that gets them thinking about the numbers, not just memorizing steps. So here we have a quick example of a game I might play with my students called Would You Rather Have? For this, I might just have 2 students come forward and discuss it. I might pull out the iPads with buzzers on them, a buzzer app, and then have them buzz in. I might have fly swatters and they slap the number that they think is larger. And then we discuss why they think it's larger. So here we have, is 17 larger or is 14 and 6/10 larger? Your students may want to say that 14 and 6/10 is larger because it has more digits. So then when I get this response, I ask this question. Would you rather have $17 or would you rather have 14? And the students will say, well, obviously, I'd like $17. That's more money. This would be the step where I'd go and I'd make a place value chart and I'd write it in, or I'd take 17 and I would write it at $17.00 and then write $14.60, and then I would ask them again to think about it. But we really want to build that rapid recall of, oh, let's look, 17 is in the tens and the ones place, 14 is in the tens and the ones place. So I very quickly can determine, oh, $17 would be more than $14. 17 is larger even though it has less digits. Let's take a look at another one. Here we have 81 or 79 and 9/10. So your students again may want to say 79 and 9/10 is larger, but ask them, which is truly larger? It would be 81 because $81 is more than $79. So there were 3 quick strategies for helping your students understand that just because numbers have more digits does not mean that they're larger. They really need to think about where that decimal is and what it means to be to the right of that decimal, meaning it's less than a whole. I hope these helped. If you have any questions, ask me below in the comments. Also in the comments are links to the wonderful people that designed the clip art and the font. Thank you.